All right, so let's take a look at this question now. Which of the following ordered pairs is not a function? What's the correct answer? Leanne? B. Why is B the correct answer? That's right, because it has -1 going to 0 and -1 going to 2. That's two different outputs for an input. That makes it not a function. Okay, next one. Quartile. First data set. Let's see here. Did you get 70?
Yeah.
Okay, good. Next, what's the product here? We're going to get 2x cubed plus 6x squared plus 10x squared. Let's see here. Let's see here. What are we getting here? Oh, plus 7x minus 21? Minus 15, I'm sorry. Minus 15. We're good on that? Okay, good. And number 4, a sequence that has initial value of 15. Each term is twice the previous term. What are we going to get? What do you think, guys? First off, is this a geometric sequence or an arithmetic sequence? No, definitely geometric, because you're doubling everything, which means that it has to have an exponent. So that knocks out choice C and D. So it's either A or B. The question is it going to be to the n power or to the n minus 1 power? N minus 1 is correct. Look, we can double check this. Let's check the third value. If I start with 15 and I always make it twice the previous term, what's 15 double? 30. And double 30 again? 60. Now let's take in choice B and let's plug in a 3 here. What's 3 minus 1? 2. What's 2 squared? 2 squared, 4. And 4 times 15? 60. So that works. If I try a 3 here, 2 to the third is 8. 8 times 15 is 120. That's not going to work. It's an extra factor of 2. Turn, face forward. Now, any questions on the do it at all? Anything? All right. So yesterday we talked about different scatter plots, and we talked about the line of best fit that would go in there, and we talked about sometimes the line, it's not even a line of best fit. Sometimes it's going to be exponential, or as we will find out, it could also be quadratic. So today we do a little bit more study about that stuff and model some relationships and so on and so forth. So let's just keep working our way through this. I don't think it's killer hard. You know, at this point, we're not spending a ton of time going over the homework. If you have homework questions that drive you crazy, you talk to each other when I'm grading quizzes and so on and so forth. You can also see me at Extra Help. The library tonight is 6:30, not 5:30. And we keep working that stuff out. The only thing is, in about another, I want to say, week to week and a half, we will be done with the curriculum. And then every day I will give you a booklet that has the answers to every single homework question in them with the work shown. And a necessary part of every lesson will be to have you compare your work to the work I do in this booklet and then bring up any questions that you might have. That way you can tell if you're doing all the questions right or wrong, and we'll be loading up on old Regents exam questions. Okay? Any questions? All right. So, sometimes the pattern in a scatter plot will look like the graph of a quadratic function with all the points falling roughly in the shape of a U. And sometimes it's an exponential sloping upwards, sometimes it's an exponential sloping downwards. What these graphs might look like would be something like this. You might have a scatter plot that looks clearly that doesn't look like a line. Or you might have a scatter plot that looks like that. Or similarly with the exponential downward sloping. Does that make sense? Okay? So in other words, not every single scatter plot leads to a line. And that makes sense because if the data given doesn't describe a linear situation, it would be there. For instance, we talked about population, and it doesn't necessarily go linearly. All right, so let's take a look at this guy. The first one what do you think, what scatter plot is it best approached with? Is it more linear? Is it more quadratic? Is it more exponential? Is it more no correlation? What do you think? Linear, all right. Would this be a positive or a negative correlation? Negative. And would you call it a strong correlation or a weak to moderate correlation? Weak to moderate, okay? Here is what I would consider to be something like a line of best fit. Oh, knock that over. Hey, behave yourself. All right, so it looks something like this. And it should be up a little bit higher, but that's more or less a line of best fit. It's a negative slope, so it's a negative correlation, and it's not strong. A strong correlation would be something like this, when all the dots are very close. A perfect correlation would be when all the dots are in a straight line. This correlation would be -1. That correlation would be +1. The one with the blue dots here might be -0.9 because it's really close. The one with the red dots would be more like -0.5. The stronger it is to a perfect correlation, the better it is to the number 1, either -1 or +1. And if it's pretty close to perfect, it's like 0.9, 0.85, something like that. If it's weak to moderate, 0.5 would be good. What about this next graph over here, scatter plot number 2? What do you think that would be, Lily?
An exponential one.
Yeah, definitely exponential, or something like that. Good. What about scatter plot 3?
No.
No.
Yeah, I don't see any correlation there whatsoever. What about scatter plot 4?
Quadratic.
Yeah, I think it'd be quadratic, something like that. Okay. Let's scroll up, see what we got coming on next. So, to me, this stuff is, remember I said to you when we got done with quadratics and that kind of thing, that this is much easier. Scatter plot 5, there is no scatter plot 5.
It's all the way in that corner.
This?
Yeah. What is it?
I have no idea what that is. No, that's not a scatter plot. That means you're skipping space. This is called a break, and it means you're jumping. If you notice, this goes 90, 100, 110, 120, 130. This is a break between 0 and 90. This is a break between 0 and 100. That's all that means. Oh, well, it says, which of the 5 scatter plots show a pattern? I don't know why there's no dots on scatter plot number 5.
Oh, there's dots.
There are there?
No. I don't know what dots you see.
There are dots there.
I don't see dots. Yeah, right, we can draw our own. Lily, what do you think?
There's 2 I have a question actually.
Got it.
For the ones that like are not like quadratic or linear, are they ever gonna ask you if it has like a positive like correlation?
Oh, when it comes to exponential or quadratic, they don't ask positive or negative. They just ask you to recognize the type that it is. All right. Which of the 5 scatter plots from lesson 12 show a pattern that could be described as quadratic? We did that. Which could be exponential, downward sloping, we did that. All right, let's go to here. Let's revisit the data on elevation and the mean number of days per year. This is what we were working on yesterday. Scatter plot shown. The plot shows a straight line that can be used to model the relationship between the 2 numbers. In grade 8, you informally fit a straight line. It says the equation of this line is 83.6 plus 0.008x. Now they're telling you the equation of a line. A little later, we will do a thing called a linear regression, and we will show you how to generate that line. For now, they're telling you the line, okay? And it's really easy. The calculator does all the work. It's the same thing as doing a box plot or doing the standard deviation. Remember how we enter the data and the calculator takes care of it? Same exact thing here. Okay, assuming that the 14 cities used in the scatter plot are representative of cities across the United States, should you see more clear days per year in Los Angeles, which is near sea level, or in Denver, which is the mile high? Now, keep in mind, sea level has an elevation of 0. That would be down here. And a mile high would be up around 5,000, which is in this region here. So more clear days by the sea level or more clear days at a very high elevation? More clear days. What does the bottom axis represent? Elevation. What does the vertical axis represent?
More number of clear
The more number of clear
Oh.
days. So when are you going to get more clear days? At sea level or at a high altitude?
high altitude.
High altitude. Very good. So you should expect to see that. One of the cities was Albany, New York, which has an elevation of 275 feet. If you didn't know the mean number of days for Albany, how could you predict this number based on the line that describes it? Okay, what you could do, x is the elevation in this formula. You see where it says the equation on the line is y equals 83.6 plus 0.008x? So x is the elevation. So in this case, x is 275. Everybody take your calculator and type in 83.6 plus 0.008 times 275. And tell me what you get.
85.8.
What did you get? 85.8? All right, now 275 is right around here, and if I go up, isn't that like right around 85? So that's what the line of best fit does. It predicts value. Is it perfect? No, but it should give you a ballpark reading on what we're doing there. Okay, number 5, another city was Albuquerque, New Mexico. It has an elevation of 5311. If you didn't know the mean number of days, how could you predict based on the line? All right, elevation is 5311. So I go to 5311, that's around here, right? So then I can go over here. And I'm looking at somewhere around 125 days.
126.088.
Is that what it works out to, 126?
0.088.
Good. Now, that's if you plugged it into the formula. And the other way was if you just eyeballed it and looked it over. And notice they came out to be pretty close to the same thing. Okay? Any questions? Okay. All right, it's time to crank on your homework. Start it up. Remember, please, every one of these questions is designed to remind you of what is coming on the Regents exam. It's a good time now to talk to each other as you go through these questions. Your efforts will absolutely bear fruit on the Regents exam. They are not meant to just take up time from you.